We're going to look at determining continuity in piecewise functions today. So looking at a graph is continuous if there's no holes, no asymptotes, no jumps. So just something continuous with no breaks anywhere. We say something has removable discontinuity if there's a hole in the graph. Okay, so we would say this graph right here has removable discontinuity at this x value. Non-removable discontinuity, that's when we have a jump, so the parts are disconnected, okay, or an asymptote, like an irrational function. Okay, so with removable discontinuity, you're able to just fill it in with a solid circle, and then that would make it continuous. Okay, but with non-removable discontinuity, you're not able to just fill in the discontinuity with a point. Okay, there's no way to make the graph continuous by just putting a point there. So let's just look at a few graphs. So use the graph of each function to determine the points of discontinuity. Name the type of discontinuity at each. Okay, so we're going to have removable discontinuity anywhere we have a hole. So if I look at the graph, I've got a hole here at -3. Now it doesn't matter whether there's a solid point anywhere. Okay, if you have a hole, meaning you can just fill it in and that would make the graph continuous, that's going to be removable discontinuity. Okay, so I have removable discontinuity at this point right here, which is x equals 3. Okay, then if I look here, here's my next type of discontinuity. Well, this is a jump because the parts of the graph are disconnected. So when it's disconnected, that's what we call a jump, and that's going to be non-removable discontinuity. Okay, because we can't just like fill in the discontinuity with a point. There would still be a gap there, making it discontinuous. Okay. So this x value is 0. Okay. Then if I look here, I've got another hole. Okay. So this is a hole because the parts of the graph are connected to it, just like over here. Okay, a jump is when the pieces of the graph are disconnected. Okay, so this one I could just fill in that hole and it would make the graph continuous. So when you're able to just fill it in, that is removable discontinuity. So that's going to give us another removable discontinuity at x equals 2. Now for our next graph, here we have an asymptote. Okay, an asymptote is always non-removable discontinuity. So this graph is going to be non-removable at x equals 3, it's just the value of the asymptote. Then if I look here, I've got a jump right here. Okay. So a jump is also non-removable. So this is also going to be non-removable at x equals 2. Okay. And there's no holes in this graph. Okay. For there to be a hole, the parts of the graph would have to be connected. So if I were to take this section right here and move it up here, that would be considered a hole, which would be considered removable. Okay. But since this little parabola and horizontal line are disconnected, that's what makes it a jump, which is non-removable. And then this last graph that we're going to look at, okay, I can see there's no holes, there's no jumps, there's no asymptotes. So there's no breaks in the graph. I'm able to just trace it without any holes, without any gaps, without any jumps, without any asymptotes. So that just means this is a continuous graph. Okay? So this graph would have no discontinuity. Or you can just say that it's continuous. So no discontinuity and continuous, same thing. So now what we're going to do, instead of looking at graphs, we're just going to look at the equations of some piecewise functions and determine whether they're continuous or discontinuous. Okay, but before we do that, let's review this. Okay, so when you're determining the type of discontinuity from an equation, okay, you're going to look at the x value. Okay, if you can plug it in and get the same number, and one of those points is closed, that's going to be a continuous graph, or continuous at that x value, okay? Because you're going to end with an open circle, but then that closed circle will pick up at the same spot. Okay. If you plug in the x value and you get the same number, but both of the points are open, okay, that's a hole, which would be removable. Okay. Well, then if we plug in the x value and we get different numbers, that's going to be non-removable because it's a jump. Okay, so let's look at some equations now. So you could go through and graph these, okay? But instead of graphing them, okay, so we just want to figure out if the function is continuous. If it isn't, we're going to identify the x values for where it's discontinuous and see whether they're removable or not removable. Okay, so what you do to figure that out is you look at the inequality. So this is x is less than or equal to -2 and x is greater than -2. So what we're going to do is we're going to look at what value we get coming from the left. Okay, so that would be the less than inequality. So I'm going to take this equation here, plug in -2 for my x, so the inequality tells us what number to plug into this equation. So -2 plus 1, that's -1. So then I would have a point here at -2, -1. And since it has an or equal to, that would make this a closed or solid point, whatever you want to call it. Okay, so closed or solid, since I have the or equal to. Okay, so this graph is going to end at -2, -1 with a solid point. Okay, then I'm going to look at the side of the graph to the right, so that would be the greater than inequality. So I'm going to plug in -2. So you square the -2 first, then multiply it by the negative, and then we're going to add 3. So that would be 4 times a negative would be -4 plus 3, which is going to give me a y value at -1. And that's going to be an open circle because it doesn't have the or equal to. Okay, so while this graph ended at -2, -1 with a solid point, the next part of the graph is going to pick right back up at -2, -1. And even though this is open, since there's a solid point, that's going to fill in the circle. So if I were to do like a quick sketch of this, this would be my y equals x plus 1. I would end right here at -2, -1. Okay. Then this graph, the parabola, would pick right back up at the same point. Even though it would be open, there's already the closed circle. And then it would just continue on forever. So we could see there would be no gaps, no breaks, no discontinuity at all. So since we got the same y value and one of them was closed, that's what makes this a continuous graph. Okay. Or we could just say no discontinuity. Now this next one, okay, we've got sine of x plus 2 and 2 minus 3x. Okay, so this time we're plugging 0 into both equations. Okay, so the less than inequality always tells us what this graph is approaching from the left. So we're going to do sine of 0 plus 2. So sine of 0 is 0 plus 2 is 2. So this graph right here is going to come from the left and end up at 0, 2 with an open circle, because I don't have the or equal to. Then I'm going to look at what happens from the right side. So that would be the greater than inequality. So I would do 2 minus 3 times 0, which is also 2. Okay, so same number, but this time both of them are open. Okay, so our sine graph, which we know would look like this, is going to end at 0, 2, so I'm just going to pretend like this point's 0, 2, and then this graph right here would pick up at the same point, but still with an open circle, so we would still have a hole here. So when you get the same number, okay, but they both have an open circle there, that's what's going to produce a hole in the graph. Okay, and so a hole is removable discontinuity. So we would say this is removable discontinuity at x equals 0. Okay. So the value that it's discontinuous at is always the x value that you plugged into the equation. So now for this one, we're going to plug 3 into both of them. Okay, so this is the less than. So that'll be the left side of the graph. So that'll be 1/2 times 3 minus 1. So that's 3/2 minus 2/2, which would be 1/2. And that's going to be a closed circle because I have the or equal to. Okay. Now this side will tell me what the right side approaches, the greater than inequality. So that's 3 minus 3, which is 0. Okay. Now if you get different numbers, we don't care whether they're open or closed. If you get different numbers, that's considered a jump in the graph. Okay, because this graph right here, the one coming from the left, would end up at 3 1/2, okay, where the next graph would pick up, and sorry, that would be a closed circle, where this next graph would pick up at 0 and go to the left. So I could see there would be a gap right there. Since I have different numbers, there'd be a gap in my y values. Okay. So anytime you get different numbers, we don't care about open or closed, because a jump, no matter what, is always non-removable. So that would be non-removable at x equals 3. Now for this next one, we have a 3-part piecewise function. Okay? So the first 2 equations are always going to share a number. Okay? So the first place I'm going to look for any discontinuity is at 0. Okay? So if I plug in 0, this is going to tell me what the graph approaches from the left. So that'll be 2 times cosine of 0 plus 1. Cosine of 0 is 1, so that's 2 times 1 plus 1. So from the left side, I'm going to end up at 0, 3. Okay, so that would be like my limit from the left. And that's going to be an open circle since I don't have the or equal to. Okay. Then the limit from the right, okay, that's going to be this one, because here I can see x is greater than 0. Okay. So from the right, that's just going to be 3 no matter what. Okay. And again, that doesn't have an or equal to, so that is also an open circle. Okay. So we got 3 for both of them, okay, but they're both open, which means we're going to have a hole at that point. So we would have a hole at 0, 3. So that means we have removable discontinuity at x equals 0. Okay. Now we need to compare the second 2. Okay, so where we could have discontinuity there is at x equals 3. Okay, it's the number they share in the inequality. So that's the next place I'll look for discontinuity. Okay. So again, in this first equation, I'm just going to get 3 no matter what. It doesn't have an or equal to, so that'll be an open circle there. Okay. Then in the second one, I'll do 1/3 times 3 squared. So that's 9 times the third, which is also 3. So I've got the same number. So this is when you need to check for if they're both open or one of them's closed. And so since this one has the or equal to, that means I have an open circle here, but this one is going to pick up at the same point with a closed circle. So it's going to fill in this hole we have right here and make that part of the graph continuous. So this part's going to be continuous at 3. So the only discontinuity we'll have on this one is at x equals 0. Now on this last one, okay, for the first 2 equations, I'm going to plug in 1. Okay, so that would be the first place. So on the left, when I plug in 1, that would be 1 minus 1 squared, which is 0. And that's an open circle. Okay. Then the limit from the right, that would be this equation. That would be root 1 plus 1, which is 2. Okay, so different numbers is a jump. So a jump is always going to be non-removable. So that would be non-removable at x equals 1. Okay. Then the last place I'm going to look for discontinuity is 4. So when I plug in 4 to this equation, that's going to give me 3 with an open circle. When I plug in 4 to this equation, that's also going to give me 3 with an open circle, which is a hole. So that would be removable at x